This graphic shows how ozone is produced. Again, the blue circle represents VOCs, and NVOC, that's non-methane volatile organic compounds, will cycle, break down into radicals. Those radicals will react with NOx if there is a source of NOx. And then that dissociates in sunlight and produces ozone. So our biggest sources of NOx in Nova Scotia, that's the green pie chart up top, are mobile sources. Hopefully we can reduce that if we start listening to Brendan. And our closest source of VOCs are actually natural sources, also called biogenic VOCs. So these are emitted from forests across Nova Scotia. So that makes our VOCs a little bit difficult to regulate because we can't really stop forests from emitting. So my methodology, all my data is taken from the National Air Pollutant Surveillance Program. That gives me hourly NOx data, hourly ozone data, and then a 24-hour average once every 6 days for VOC concentrations. And there's 160 different VOC species. This map shows all the different stations that monitor gases across Nova Scotia. They're not always active, but between the period of 2000 to 2017, they go on and off. Some of them go on and offline quite a bit, but my three main stations that I use for this project, Aylesford, Lake Major, and Halifax, are online most of the time between 2000 and 2016. I chose these stations because they are, along with data availability, they're also very geographically different. So Halifax, that's where most people in Nova Scotia live. It's an urban center. We have lots of pollution sources. Lake Major is a suburban area, so there's no large source of emissions in Lake Major, but a lot of Halifax pollution is blown downwind to Lake Major. And then Aylesford is a remote station. It's also almost 300 meters above sea level. So there's no local sources of emissions there, but because of its elevation, it receives a lot of pollution that's transported up from southern Canada or the States. And all my trend analyses are done in R and MATLAB. So to start, this is some annual trends of hourly ozone at my three study stations. So I've done all the analyses you will see from 2000 to 2016. I just recently added in 2017 data just for these plots here, and it pretty much changed around everything I was going to say today. Because you see for 2017, which is the last box in each of these plots, there's actually a rise in 25th, 75th percentiles, the medians, and even the highest outlier values have all risen from 2016 to 2017 at all these stations. So other than that, we see a rise in the 25th percentile ozone in Halifax. That's not much to be concerned about. We can't really do anything about that because that has to do with global background levels that are rising. However, median values, once I put in the 2017 data, are rising at all stations now. And that's seen, it's hard to see, but the medians are the black lines in the middle of the boxes. And then the fourth highest hourly values are decreasing at Halifax and Aylesford. That's good. So those are the highest values that would give the most harmful health impacts. But the fourth highest value is now increasing at Lake Major. So a deeper dive into Halifax ozone, because it behaves a little differently than ozone at rural stations. We have a lot of nitrogen oxides here because our station is located on Barrington Street where there's lots of vehicle traffic. So our ozone is actually titrated. So when we look at the red line here, which is just your annual average ozone throughout the study period, it seems like it's very slightly rising at 0.18 parts per million per year. But this is not the way you want to be looking at ozone in a very urban area. We actually want to look at something called total ozone, and that takes the ozone concentrations and then estimates the amount of ozone that has been temporarily titrated away. So we get a better look at what the ozone is actually doing without that temporary titration effect. And the temporary titration effect is modeled as DO3. And that is NO2 minus 10% of primarily emitted NO2 emissions, and that's just a widely cited way to estimate the titration effect. So total ozone is just the blue line plus the red line, you get the green line, and that is actually decreasing over this time period. And that makes a lot more sense because our NOx emissions had also decreased. So there's less titration and our total ozone levels are going down. So now I'm going to talk about the two precursors to ozone, starting with NOx. So I have NOx emissions from the National Pollutant Release Inventory over the study period. And that's all reported NOx emissions from large point sources. And those are steadily decreasing over this time. You can see that in the orange. And then in the black is just our annual average NOx concentrations, and that's from the NAFS database. So both are steadily decreasing over the time period. However, I redid the regressions for 2012 to 2016, and I found that the emissions are actually decreasing a lot quicker during that time period, but our concentrations, what our station down on Barrington Street is picking up, actually does the opposite. So the trend is decreasing less rapidly between that time period. So there's something going on where our concentrations that we're seeing are not following the same as our local emissions, which hints to me that something else is controlling our concentrations here, not just our own local sources of emissions. So next I want to look at the second precursor to ozone, and that's VOCs. But in order to do that, to look at the 160 VOCs that NAPS offers me, I have to look at the ozone formation potential because not all VOCs contribute equally to ozone formation. So what I do is I take the maximum incremental reactivity, which is just a constant, and each of those VOCs has a different constant. And I multiply that by their concentration. So I average the concentration of each VOC over the year, multiply it by the constant, and then I get the ozone formation potential of each of those VOCs, and that's given in grams of VOCs, grams of ozone produced per gram of that VOC added. So when I plot this over the time period, I see that VOC emissions, VOC concentrations, and the OFP, the ozone formation potential of all VOCs, have again decreased throughout the study period. And between the years of 2012 and 2016, the slopes are kind of leveling off, so we're not seeing the same decrease as we have in older years. Something else I did on this plot, if you can remember back to that pie chart on one of my first slides that shows that natural sources of VOCs, looks like it is the majority of VOCs in Nova Scotia. I plotted just the biogenic VOCs in terms of their OFP, because you would think if the majority of VOCs come from biogenic sources, the majority of VOCs contributing to ozone should also maybe come from those natural sources. However, in black here is the biogenics, and it actually just makes up a very small proportion of the total VOC ozone formation potential. But that is getting increasingly more in proportion to the anthropogenic VOCs. So we are decreasing our anthropogenic VOCs. We can't decrease our biogenic VOCs. So the proportion of biogenic in the coming years will be more. For example, in 2016, the biogenic VOCs actually makes up about 1/10 of all the VOC ozone formation potential. And then I wanted to look at what was happening on the days in Halifax that had very high ozone. So this is a histogram of all hourly ozone in Halifax from 2000 to 2016. It's a high-tailed distribution, as most air quality is. So in these top 1% events, what is causing us to have high ozone? So the range is from 44 parts per billion up to 87 parts per billion, and this is from 2000 to 2016. And there is 1,489 instances in these top 1% ozone. So I wanted to see if this is caused by our own local emissions or if it's caused by something else like transport emissions from away. So what I do is I'm using spatial correlation to see the difference between a local ozone event versus a transported ozone event. So on this map, each of the yellow circles represents a station. The number in that yellow circle represents the maximum hourly ozone on the day of the high ozone in Halifax. And then the number beside that in black is the percent change from the monthly mean at each of those stations. So for example, in Halifax on this day, we have a high of 75 parts per million. That's over 300% above its monthly mean. But when I extend analysis to the rest of the province, there's actually some negative anomalies, or it's right around their monthly means. So there's no signs of high ozone above the monthly means of the other stations. So that shows me that this is a local production event. This was isolated to just Halifax. In comparison, when we're looking at transport events, I find that there's a high ozone day in Halifax, over 100% above its monthly mean. I extend the analysis to the rest of the province, and I see that all the stations are showing very positive anomalies for their monthly means, and that shows me that this is a transport event, because many of these stations do not have local sources of pollution. So it would have to be something brought in province-wide from somewhere else. So in order to look at these, pick out the 1%, so the 1,489 days for the entire time period, I ran it through a code that sorts the days into either a transport event or other, perhaps a local event. And I use the criteria where 80% of stations on that day show anomalies of 70% or higher of their monthly mean, and that would be a transport event. If it doesn't meet this criteria, it falls into the category of a local event that could potentially still be transport. It might just not meet the stringent criteria. And when I do this over the 16 years of data, I see that 34% of these 1,489 events fall into the transport-related criteria. And we can see most of these are happening in the earlier years. It's falling when we get into the more recent years. And if I overlay this with the percent transport events of the percent of the high ozone events per year, I can see that the percentage transport events is also falling. And in summary, so our ozone precursors, NOx and VOC emissions, are decreasing faster than the precursor concentrations that our stations are picking up, which shows that there's something else influencing these concentrations that we are seeing in Halifax and also at other stations across Nova Scotia. 34% of the top 1% ozone events are transport related. They did fall into my transport criteria. Now this doesn't mean the other 66% are not transport. It's possible that the transported pollution might not make it all the way up to Cape Breton on some days. It might not make it into areas of our northern air zone on some days. So therefore it would not meet my criteria, but there's likely a higher percentage than 34 that is transport events. Our elevated ozone events are decreasing, but there is a high variability in the transported fraction per year. That was the last plot I saw. You can't see a very clear trend in those. And as the transported fraction is decreasing, this inherently means that the local production events are becoming more important. So what I'm going to do in the future is obviously adding the 2017 data to that transport analysis. I want to see if there's a spike in the transport events in 2017, because there's a spike in all the other trends in 2017. I want to see what's happening on those local ozone production days, if it's mostly caused by biogenic influences or anthropogenic influences, and then when we are receiving a transported pollution event, where is that coming from? So I'm going to be using a backwards trajectory analysis like high split, and then GeoSChem as well with the help of our postdoc Ian, who you'll hear talk later. And then we can see where that's coming from, if it's primarily southern Canada or the northeastern US, as it has been in the past, or if it's coming from elsewhere. And that is everything.
Have you looked at the ozone production regime we're in as a function of time, so like NOx and VOC limited?
I have done a little bit of that because I was able to get NOZ data from someone, and it looks like most of the time we are limited by VOCs but that's at the downtown station, so it'll also help having the observatory at SMU that's away from that downtown area, because we're not really sure how far that NOx bubble stretches out, if it's just in the downtown region or if it's the whole Halifax Peninsula. But I will be doing more on that.
It'd be interesting because if you're beginning your time season at very high NOx concentration, so if you're changing regimes during your trend analysis.
Yeah, definitely. And if we continue to decrease our NOx, we will be going to a more NOx limited production regime.
Is any of your data capture for Lake Major around when they were doing the work for the dam replacement?
I'm not sure. So when was that?
Maybe that was like between 2017 and 2019. So they replaced the dam, and I think they also flooded a little bit more of the area up there. So I'm just wondering if
Okay, I haven't looked at the 2017 data yet, but
Okay.
I'll
keep
keep
in
that in
mind,
mind. Yeah.
they did do a major dam replacement up in that area, and I think they did take in some extra like wetland area
Okay.
as part of the flooding.
Okay.
They also did install the generator for the station, so you probably see instances that maybe we haven't caught yet where you'll have higher NOx.
Right.
They're pretty easy to see though, but not so
Yeah.
I was kind of curious about the decrease in the number of transport events and wondering how that looks to the criteria in that the weather regimes that transport pollution probably haven't changed that drastically over time.
Right.
So part of it might be what's coming with the transport events is decrease in severity, and that would link up with emission reductions in the northeastern U.S. But there's still kind of a question of how that links into rising trends in 2016, 2017, and how that all plays out from a number of basis. So I'm kind of curious about those criteria and how it links into the bigger story of what's going on in ozone in the last year and things like that.
Mm-hmm. And just a little bit more on that, interestingly, there was a paper published about increasing emissions in 2017 in northeastern USA and why that's going on. So.
Thank you.
Thanks a lot. And I left a little bit of time at the end of these three sessions, so no one, feel free to talk and ask questions, because there's about 15 minutes until lunch. Okay, so our next speaker is Jim LeBlanc, an occupational hygienist with the Occupational Health and Safety Division of the Nova Scotia Department of Labor and Advanced Education. In his current role, he's involved in the anticipation, identification, assessment, and control of physical, chemical, biological, contaminants, and psychosocial issues in the workplace. Jim has been involved in delivering occupational health and safety services both in the field and as a manager within the province. He has been active contributing member and representative for Nova Scotia on numerous federal, provincial, and territorial committees over his 30 years of practice. Thanks, Jim.
All right, thank you very much. And good morning. So I'm going to take you from the outside world to the inside world. And the presentation that I'm going to provide today is really about a case study of an air quality assessment that was done in a provincial government building. But before I do that, I guess I need to do a normal disclaimer that it's just for general information. If you've got specific questions about the programming or the regulations that we administer, feel free to give us a shout. I've left some business cards up here by the projector if anybody wants to get in touch with either us or the branch after we finish. So maybe a bit of background with the Department of Labor and Advanced Education, and basically we're a bunch of folks that are really focused on education, learning, and workplaces. So as you see, we're a pretty diverse organization: skills and learning, labor services, higher education, safety, volunteerism, and we have corporate policy and services section. So the safety branch is really made up of two sections, so technical safety. And technical safety is involved with boiler and pressure vessels, so the inspections and the licensing of those, elevators and lifts, amusement devices, certified power engineers and crane operators, fuel safety and electrical safety. So that's on the technical side of the safety branch. In the occupational health and safety side, we're kind of divided into two groups: the compliance and inspection services. So there's around 50 staff basically that are involved in day-to-day inspections and investigations of accidents around the province and the inspection of workplaces. And technical and outreach services. So I'm part of this division, and really we're a specialized service within the organization. And as Lance mentioned, we're involved primarily in the assessment of physical, chemical, and psychosocial agents in workplaces. So there's also some, I guess, promotional resources that are available within the technical and outreach service section. So what I'm going to talk about today, and we've already talked about the department in terms of how it's organized and what services it's provided. Just a bit of fundamental information in terms of the workplace health and safety laws in the province. And then we're going to review this case study. So in terms of health and safety legislation, it's all based on this concept across Canada that's known as the internal responsibility system. And there's a sense in that framework that everyone in the workplace shares a responsibility for occupational health and safety. So if you're part of the workplace, it doesn't matter how you're characterized, employer, contractor, owner, employee, there are things that you can do in relation to the health and safety in your own workplace. And there are people that are outside the workplace that contribute to it. So contractors, suppliers of goods, and collectively, we all have that responsibility. And government, for better or for worse, creates the regulatory framework that we all operate in and is really available to make sure that the folks that have the direct responsibility in workplaces are delivering on what those responsibilities are. In terms of structurally, on the far, my right side, your left side, the Occupational Health and Safety Act is sort of the foundational piece on which everything is based. We also administer the Hazardous Products Act in the province in terms of the relation or the portion of that legislation that refers to hazardous materials that go into workplaces. We also are responsible for the Smoke-Free Places Act in workplaces. Restaurants, bars, someone else's responsibility, but we would do workplaces. And underneath the legislation, which is the sort of the motherhood document, there's a bunch of regulations that we administer. And the ones that are under the Occupational Health and Safety Act are listed in the top half. And we're going to focus a bit on the workplace safety and health regulations, because that's basically where the authority comes for dealing with chemical exposure in workplaces. On the far, your right side, just in terms of structure, so the acts are the motherhood stuff, the regulation provide the detail, and then codes of practice are individual things that can be administered as practice, as acceptable workplace practice, but they're usually pretty well defined. So there's a code of practice for leading workplaces. There's a code of practice that's available in relation to temporary workplace traffic control. So it's very specific, provides a lot of detail in terms of what the minimum requirements that we would consider acceptable to be. And then beyond that is a guideline document, which is just really a good practice document. So it's a lot of information that's not necessarily an enforceable requirement, but it's intended to help people get to a best practice position. So structurally, that's kind of the rules and the way we operate. And the last little regulatory piece, I guess, in terms of the organization, we've identified this concept of pathways to compliance, which really involves 4 elements. So promoting compliance with the standards that have been established, setting those requirements, sometimes in law, sometimes just in good practice documents, verifying compliance through inspection, and sometimes investigation. And the final piece is the enforcement piece, which occurs either through administrative penalties, orders, tickets, and prosecution. So that's sort of the legislative framework that we work in and what the department is. I'll stop there if there are any questions on that piece. All right. Workplace health and safety regs, they're generally applicable to any workplace in the province. So the province is responsible for everything in provincial jurisdiction. So there are some industries that are excluded that are federally regulated. So things like provincial trucking, banking, telecommunications. So there's some sectors of the Nova Scotia economy that aren't provincially regulated. But the workplace health and safety regulation is really a bunch of general requirements that are in there in terms of establishing practices that would be considered acceptable, requiring consultation in the workplace with the parties that are there. And the one that's highlighted in bold, little laser pointer here, is the adopting the chemical and physical agent exposure standards that are permissible in workplaces. And for the purposes of Nova Scotia, what's been adopted is the American Conference of Governmental Industrial Hygienists Threshold Limit Values and Biological Exposure Indices. And that's a document that's updated annually. And there's a 2-year notice of intended change process that goes through as these standards are adopted. So this is an American organization. It's a not-for-profit. Even though it's called Governmental Industrial Hygienists, it's really a group that was established back probably after the Second World War that started looking at standards that could be applied in workplaces in terms of trying to control occupational exposure to chemicals. And they basically these standards have really been the seed document for just about every government in the world that has established chemical exposure standards and physical agent exposure standards. So even though I think Ontario, British Columbia, OSHA, the Occupational Safety and Health Administration in the States all have their own lists now, they all started from some version of these ACGI HTLVs. And if you look in the book, and I clicked this page up in particular because I know you're talking about carbon monoxide later on today in terms of isorenas. And if I can find it, so there's the carbon monoxide exposure in workplaces. And so in terms of an acceptable exposure limit, carbon monoxide, you can work in an environment, you can legally work in an environment at 25 parts per million for 8 hours a day. There are excursion factors that are associated with those standards. You'll notice on the table as we look at carbon monoxide, there's also BEI, which is biological exposure indices. So there is a carboxyhemoglobin is a chemical that you can look at in blood to determine what your carbon monoxide exposure has been. So it's there's also one of those that's in there. And there's other notations like this, the A4 notation that you see for carbon disulfide is that the chemical's been reviewed from the perspective of a carcinogen, and A4 is not reasonably expected to be a carcinogen. A2 is basically, there's evidence in animal studies that indicate that it is cancer causing. So, and there's just a quick summary of basically what the standard is based on. So in some cases, it's peripheral nervous system impairment, liver damage, respiratory irritation. So there's a summary of where the standard is coming from, what it's based on, and there's documentation that supports each of these standards. So the scientific research is reviewed by the organizations in terms of what's going on. Sue, stop there again. Anything on chemical exposures, where the standards are coming from, what they're about? Okay, good enough. So this is kind of the substance of what I want to talk to you about today. So it's a provincial government building, and there's really nothing unique about it. It's a single-story building. There's 2 wings associated with it. It's all on slab-on grade for the upper part of the building that you see there. The other wing of the building has a basement underneath it. Here, that's the basement area. So, this was originally a residential facility